You tap a piece of glass, and the world responds. A message sends. A photo moves. Money transfers. An entire business runs. But here's the strange part. Your finger never actually presses a button. There are no moving parts. And yet, the phone knows exactly where you touched. So what's really happening when your finger meets a touchscreen? Today, we're pulling back the glass, both literally and scientifically, to reveal how mobile phone touchscreens actually work. By the end of this video, you'll finally understand something most of us use thousands of times a day without ever truly knowing how. Let's start with the first big truth. Your phone is not feeling pressure. One of the biggest misconceptions is that touchscreens detect pressure, or maybe feel heat, or sense your skin. Modern smartphones do none of these things. Your phone doesn't feel your finger. Instead, it detects changes in an electric field. That right there is the key. So where is this electric field? Beneath the smooth glass surface of your phone lies an ultra-thin, transparent grid made of a material called indium tin oxide, or ITO for short. ITO is special because it both conducts electricity and is almost completely transparent. This grid forms thousands of tiny, invisible intersections across your screen, and each one of those intersections holds a small, stable electrical charge. Together, they create a constant, stable electric field, like a silent, invisible net stretched across your display. Now, what does your finger really do? Well, your body is a natural conductor of electricity. So when your finger touches the screen, it absorbs a tiny amount of electrical charge from that specific spot. This disturbs the electric field at that exact location. Your phone doesn't sense your finger itself. It senses the disturbance your finger causes. This amazing process is called capacitive touch sensing. You might remember older touchscreens feeling very different. Early screens, like those on old ATMs or GPS units, used resistive technology. They had two flexible layers that you had to physically press together to make contact. They worked with gloves or a stylus, but they felt slow and less responsive. Modern smartphones use something called projected capacitive touchscreens. These require no pressure, support multi-touch gestures like pinch to zoom, and are incredibly precise, responding in milliseconds. This shift is what made our smartphones feel so alive and intuitive. But how does your phone know exactly where you touched? This is something that's rarely explained clearly. Your screen doesn't just detect a touch at a single point. When you touch it, it measures changes across multiple nearby grid points. Then it compares the signal strengths from all those points and uses complex algorithms to calculate a single, precise location. This is why swipes feel so smooth, why pinch to zoom works, and why your phone can track continuous motion, not just individual taps. Touch input is being constantly mapped, not just detected one tap at a time. This continuous mapping is also why multi-touch is even possible. Each of your fingers disturbs a different part of the electric field. The grid is powerful enough to track multiple disturbances simultaneously, and the software is smart enough to separate and interpret them as distinct touches in real time. Your phone isn't just detecting touch, it's tracking multiple moving electrical events at once. That is some seriously advanced signal processing, happening thousands of times per second. This all explains why your regular gloves usually don't work with your phone. A normal glove is an insulator. It blocks conductivity. No conductivity means no disturbance to the electric field, so your phone simply ignores it. But what about those special touch-compatible gloves? They have conductive fibers woven into the fingertips. These fibers extend your body's natural electrical properties through the glove, allowing the charge transfer to happen. The screen still isn't detecting the glove, it's detecting your electrical presence through it. Of course, the hardware is only half the story. The software is where it gets really powerful. The hardware detects the touch, but the software is what gives that touch meaning. Your phone's operating system is constantly working behind the scenes. It filters out electrical noise, predicts the motion of your finger, compensates for the screen size and the angle you're holding it at, and even adapts the touch sensitivity dynamically. Modern phones take this even further. They use AI-assisted algorithms to predict where your finger is going next, reducing latency and making the experience feel instantaneous. This is a big reason why newer phones often feel faster, even when the hardware specs seem similar. Have you ever gotten your phone wet and seen it go crazy with ghost touches? This happens because water also conducts electricity. When water droplets hit your screen, they disturb the electric field randomly. The screen's sensors misinterpret these disturbances as your fingers, and you see taps and swipes you never made. Water isn't pressing the screen, it's just confusing the electric field. This is why many phones have features that automatically disable touch controls when they detect they're wet, or use special software filters to try and reduce these false inputs. And what about the glass itself? It's not just ordinary glass. The glass on your phone's screen is usually chemically strengthened, like Gorilla Glass. It goes through an ion exchange process to increase its durability and make it resistant to scratches and microfractures. It has to be incredibly hard, perfectly transparent, electrically neutral, and microscopically smooth. This glass is a masterpiece of structural and optical engineering, not just a simple protective layer. This also explains why screen protectors can sometimes reduce touch sensitivity. When you add a screen protector, you're increasing the distance between your finger and that electrical grid. This can slightly weaken the electrical interaction and alter the signal strength that the sensors receive. High-quality protectors are engineered to preserve this capacitive property and minimize any signal distortion. Cheaper ones often aren't, which is why they can make your phone feel less responsive. Here's something else to think about. Your touchscreen never really sleeps. It's constantly scanning for touch, hundreds or even thousands of times per second, even when you aren't touching it. This constant scanning is why your touch feels so instant. It's also why battery optimization is so crucial for modern phones, and why display controllers are highly specialized, powerful chips. Your screen is always listening. This brings us to styluses. Why do some work and others don't? A basic, cheap stylus simply has a conductive tip that mimics your finger. It works by conducting a small amount of electricity, just like your skin does. But advanced styluses, like an Apple Pencil or an S Pen, are a completely different technology. They communicate digitally and wirelessly with the screen, transmitting data about pressure, tilt, and angle. They use their own active capacitive systems. So, a simple stylus just pretends to be a finger, while an active stylus has a direct conversation with the device. So what's the future of touchscreens? Well, they're already evolving beyond just touch. We're seeing emerging technologies like force sensing, under-display fingerprint scanners that map your entire finger, and advanced haptic feedback that simulates the feeling of different textures. We're also seeing hover detection, which can sense your finger before it even touches the glass. And of course, foldable and flexible screens that are changing the very shape of our devices. Soon, screens won't just detect touch, they'll understand our intent. Let's bring it all back. The next time you touch your phone, remember what you're really doing. You aren't just pressing a piece of glass. You are interacting with invisible electric fields, a microscopic sensor grid, real-time signal processing, and advanced materials science, all happening in a space less than a millimeter thick. This isn't just convenience. It's modern physics working invisibly in the palm of your hand. If this explanation made you see your phone in a whole new light, do me a favor and like this video. Share it with someone who loves learning how things work. And if this really blew your mind, comment with the phone emoji down below. Make sure you subscribe for more deep but simple explanations of the everyday technology that surrounds us. Thanks for watching, and thank you for being curious.